Greetings. My name is Bea Movido, and in this presentation, I will be sharing a brief overview of my undergraduate thesis entitled Using Network Analysis to Assess and Plan for the Robustness of the Meralco Power Grid. Essentially, the problem we are seeking to address in this study is the grid's vulnerability to nodal failures and edge removals, which can manifest as system breakdowns or attacks on the network. Given that Meralco is the sole distributor of electric power in Metro Manila and some of the surrounding regions, it would be advantageous to its many customers if the network's susceptibility to these events is minimized. The objectives of the study were thus to describe the robustness of the network and identify the most vulnerable segments of the power grid. Using this information, we then proposed strategies to improve overall grid stability for future network expansion. In working towards these objectives, the first step was to create a model of the Meralco power grid. This was done by collating data about its structure and components from the Meralco and DOE websites, the Transmission Development Plan, and OpenStreetMap. The Network X Python package was then used to configure it into the model shown in Figure 1. Its features and properties such as degree distribution, clustering coefficient, and betweenness centrality were then analyzed. Here we take a network science perspective, so electric power dynamics and energy engineering principles are not taken into account. We apply 4 different algorithms to evaluate network robustness to random node disconnection, degree-based disconnection, betweenness-based disconnection, and random edge removal. We find that our model is relatively more robust to random disconnections as compared to targeted ones. To provide further context to our results, we compare them to the results obtained when the same algorithms are applied to Watts-Tragot small world networks of different p-values. With these as a reference, we are able to better understand our model and identify ways to improve its robustness. From here, we also propose alternative network configurations that may lead to better system performance.